As we burn more and more fossil fuels, CO2 is released into Earth's atmosphere. In addition to causing global warming, it is adversely affecting the oceans. When more CO2 is in the atmosphere, it is absorbed into the sea. Here, some CO2 reacts to form carbonic acid. As a result, Earth's oceans are getting more acidic, causing destruction to sea life, especially coral and shellfish. As much as 25% of marine animals are dependent on coral. One solution to the acidification problem is to encourage the growth of water plants that consume the CO2 in the process of photosynthesis before it forms acid. To find out which plants would be best suited to this task, both freshwater and saltwater, I studied the CO2 use of several types of plants. The plants I used were Ceratophyllum demersum, or hornwort, in the upper left-hand corner, Alodia canadensis, or Alodia, in the bottom left-hand corner, Ulva lactuca, or sea lettuce, in the upper right-hand corner, and Saccharina latisma, or large brown kelp. Hornwort and Alodia are freshwater plants. Sea lettuce and large brown kelp are saltwater plants. I tested the plants by placing them in tanks under a full-spectrum lamp. I used pH strips to measure the pH daily. My results showed that for the freshwater plants, hornwort used the most CO2. Its average pH was about 22% higher than for the Alodia. Keep in mind that a higher pH means lower acidity. For saltwater plants, sea lettuce used the most CO2. Its average pH was about 7% higher than big brown kelp. The freshwater plants made a massive difference to their habitat's pH level. The starting pH for hornwort was 5, and it ended at 8. The saltwater plants made only a slight difference to their environments, but given more time, I think the difference would have been higher. Unfortunately, this experiment is not perfect. I could not obtain certain plants, such as giant kelp, that have a high growth weight and therefore a higher rate of photosynthesis and CO2 consumption. If this experiment was carried out with the resources to test a larger variety of plants, it would yield more accurate results. Then, world governments could preserve the habitat of, or pass laws to protect, the most CO2 consuming plants, thereby preserving the ocean's vast networks of life.